In the last lesson, we talked about what an inequality is. We even got into a little bit of how it represents some real life scenarios. And that's really the whole goal here, is to be able to apply inequalities in a real life setting so that we can use math outside of the math classroom. To do that, we've got to kind of expand our repertoire here. So we'll continue with this lesson, and our target for today is to solve inequalities by adding and subtracting. As a warm-up, go ahead and solve these three equations at the top. X plus 4 equals 8, 3 equals 8 plus b, and x minus 0.25 equals 5. Write down the learning target and solve those three equations. Hit pause now, and then hit play when you're ready to resume. So those equations should have been pretty easy for you. As you can see in number 1, we subtract 4 from both sides. The opposite of adding is to subtract, and you get x equals 4. In the next one, you have you're adding 8 to b. So to get b by itself, we would subtract 8, and 3 minus 8 is negative 5. And then in the one all the way to the right, x minus 0.25 equals 5. So opposite of subtracting a quarter is adding a quarter, and you get 5.25. Let's get into, that's just a quick review of equations. Super simple. You could do that with your eyes closed, standing on your head in the corner in the dark. Looking at number 4, going back to what we learned last lesson, this inequality is x plus 4 is less than 8. If I put that into words, that would mean any number that I add 4 to has to be less than 8 in order to make this true. So what's a number I can add 4 to that would be less than 8? Well, I can rewrite this without that plus 4. I can get that 4 out of there just like I did with equations. Well, if I subtract 4 from both sides, I get x is less than 4. And now you'll notice this looks very much like the inequalities we were graphing last time. So this tells us right away that our dot's going to go at 4. So I'm going to put 4 on my number line, 5 on this side, 3 on this side. Maybe just beef it up a little bit with a couple more. Open dot or closed dot? Well, let's think about what's happening at 4. This is not or equal to. This is just x is everything less than 4, but this is not including 4. It's not inclusive. So we put an open dot. Okay, maybe let me change my color so it pops a little more. And then x is everything less than 4. Well, if I take my test points, let's say I take 2 and I take 6. 2, if I take 2 and I plug that in for x, 2 is less than 4. That's true. If I take 6 and plug that in for x, no, that's not true. 6 is not less than 4. So my ray can't go this way. It's got to be going toward everything less than 4. Okay? Next one. This is saying 3 is greater than or equal to 8 plus b. So in other words, if I add b to anything, or if I add 8 to this number b, it's got to be less than 3 in order to make it true, less than or equal to. So solving this, solve it the same way you solve equations. Notice this is exactly the same question as the warm-up, only now it's greater than or equal to. The opposite of adding 8, subtracting 8. So if I rewrite this by getting the 8 out of there and putting it on the other side, kind of combining like terms, so to speak, I get negative 5 is greater than or equal to b. So that tells me I've got an open dot here, and it also tells me it needs to go at negative 5. Sorry, not open dot. This would be a closed dot because b is less than or equal to negative 5. So we're including negative 5 as one of our solutions. Next, we need to take our test points to see which way the ray is going. So to do that, I'm going to take negative 6 and negative 2. Well, if I take negative 6 and plug it in for b, notice that it says negative 5 is greater than negative 6. That's true. If I take negative 2 and plug it in, negative 5 greater than negative 2? No, not true. So this ray has to go this way. Okay, and then the next problem we have here, you notice it's solved the exact same way. We have add 0.25 to both sides, x is less than or equal to 5.25. So notice it's or equal to. So we're going to put a closed dot at 5.25, which is a fourth of the way. So a fourth of the way would be right about here. Here's halfway, and a fourth is half of that. So we go fourth of the way there. It's a closed dot because x is less than or equal to. Got to figure out which way the ray is going. Notice how x is less than. We'll look for numbers that are less than 5.25. So 4 is less than, so we're going to go toward 4. Okay? So basically, the only thing new here is the graphing. The solving part of it is super simple. Everything we did back in Chapter 2, and even earlier than that, you're just doing that again in Chapter 3. So let's get into what it's like to write these inequalities, then solve them, then graph them. So there's the only extra step we're adding here is the writing part of it. A couple helpful things to know. When it says no more than, we talked about this the first time, that means we're not going over. But we are including. We could include that number. The example from last time was the crew team can be no more than 165 pounds. That was in the last video. So that means we could be 165, but we can't be more than that. So that's less than or equal to. At most, another way of most would mean kind of the same thing. I can be this amount, but no more. So that's also. Another one would be no less than. So it could be no more than, no less than. No less than would be greater than or equal to. One more, at least. At least, so the lowest you could be. That would also be greater than or equal to. Okay, so you have to be at least this much. Okay, so on here, notice how it says 6 more than. This is an English sentence. We're going to change it to math. So it says 6. So I'll put 6. More than means we're going more than something. We're going more than a number. So 6 plus a number is no more than 12. So this sum here, 6 plus a number, cannot go over 12. So it's got to be less than 12 or equal to. Okay, just like we said over here, no more than. So now we're going to solve it and graph it. Opposite of adding 6 is subtracting. So x is less than or equal to 6. Quick number line here then. Okay, here's 6, 5 here, 7 here. We're going to do a closed dot on 6. And x is everything less than 6. So if I put 5 in, it works. If I put 7 in, it does not. So we're going back this way. Okay, a number decreased by 4. So a number, that would be something we don't know, that's our variable, decreased by, so subtracted by 4. Okay, so we'll take x minus 4 is less than 6. So this difference of x minus 4 must be less than 6. Solving it then, opposite of subtracting 4 is adding 4. So x is less than 10. Quick number line here. This should be becoming second nature for you by now, if it isn't already. Notice how x is less than 10, but we're not including 10. So we have an open dot, and x is everything less than 10, so we're going to go back the other way. So let's look at a couple word problems then, okay? Again, this is just taking it one level, so rather than just doing a little sentence, we're doing a whole paragraph here, and we're going to pull some phrases out of here. Verizon phone plan includes 4 gigs of data. You've already used 2.6 gigs. If you go over, your parents will ground you for a month. Not a pleasant situation. Write an inequality that will allow you to find how many gigs you have left in the month of November. Because you cannot go over, okay? So that would be, you gotta be less than. So let's talk about what we don't know. What we don't know is how many gigs, okay? So let's define a variable here. Let's do G for gigs, okay? And that would be gigs left in November, okay? Well, what we have here is, so far we have 2.6. That's how many you've already used. And you could use a certain amount more. We don't know how much that is, so we need to add G to that. So 2.6 plus G would be how many gigs you would use for November. However, that amount you use, that 2.6 plus G, cannot go over 4. So we have two parts here. We have what we actually use on the left side and what we could theoretically use on the right side. Comparing those two quantities would say that I have to be less than, what I actually use must be less than 4. You could use 4. You're treading in dangerous waters. They're getting really close to being grounded. But if you use 4, you're okay. Just can't go over 4 is the rule. So I got to solve this now. Subtract 2.6. And 4 minus 2.6 is 1.4 gigs. So the gigs you use, the gigs you have left, you can't go over 1.4. Okay. Here we go. School bus can safely hold no more than 36 people. After 6 stops, there are 31 people in the bus. Write, solve, and graph an inequality to show how many people can safely ride the bus. Go ahead and write and solve this inequality, but hold off on the graph for now. I want you to pause the video and then hit play when you're ready to see the solution. Okay, so you can hold no more than 36. So that's kind of the key there. No more than means I can go less than 36, but I can't go more. I could equal 36. That would be okay as well. There's already 31 people on the bus. So what don't I know? Well, I don't know how many additional people. So let's say X is the number who could still fit. The number who could still fit on the bus. Okay? So we have 31, and we're going to fit X more people. Well, here's what that looks like. 31 plus X. So to figure out how many more could fit on, whoops, little math mistake here. Here we go. That's way better. Just remember, nobody's perfect. Subtract 31 from both sides. So X is less than or equal to 5. So when we graph these, fix my numbers down here too now. When we graph these, obviously my dot goes at 5. I got 4, 3, 6, 7. My dot goes at 5. Okay, because I could fit 5 people on. That would put me at 36. And I could fit 4 and 3 and 2. I could fit 6 in. The problem is, if I put array here, think about what that means. If I put array here, that means I would be putting 4.5 kids on the bus, or 3.75 kids on the bus, or 1.2 kids on the bus. I hope you realize what's upsetting and wrong about that. If we put a half a kid on the bus, or 3/4 of a kid on the bus, we'll probably need to go straight to the police station, at least to the hospital. Can't have half people, fractional people on the bus. So on this question, using array doesn't actually make sense. Let's see if I can actually erase this. There we go. A little lag attack here. So using array doesn't make sense. So what I do instead is I can put dots at each of the whole numbers. Here's 1. I better number these. 2, 1, and 0. Now, X could be 0. I could fit no more people on. This is where it stops, though, because if you think about it logically within the context of the problem, you wouldn't put a negative person on the bus. Okay? So this graph now shows all the solutions. So X equals, on this one, 0, 1, 2, 3, 4, and 5. Okay? All right. On the next one, go ahead and pause the video, read this paragraph, and see if you can figure out how to do this. We're going to just do adding or subtracting, though. Okay, so now that you're back, let's say I took x and I subtracted 3 from x. I got to keep it less than. Well, the thing is this. If I subtract 3 from x, that means 7. If you think about how you're going to solve this, I'd have to add 3 to get this to be 7. So think about this. What would I have to add 3 to get it to equal 7? Well, 4. That's just one possible solution you could do. All right, one more little thing here. Little closer activity. Doing a little logic here. I'm going to say whether this is always, sometimes, or never true. So the first one says a plus b is greater than a minus b. Is that always, sometimes, or never true? Well, the answer is sometimes. So wait a minute, if I add 2 numbers, isn't that always more than subtracting 2 numbers? Well, what if you've got negatives, right? So what if b is negative and a is positive? If I do a positive minus a negative, remember subtracting a negative, same thing as adding a positive. So that would make this larger, because if I have a positive plus a negative, that would work against each other. So got to be careful, don't forget about negatives, which will probably help us on a couple to come here. A is greater than C, so if A is more than C, then A plus B is greater than C plus B. Well, think about what you're doing there. You're adding B to both A and C. So you're adding B in both situations here. Well, if A is already greater than C and you add the same number, well, that's not going to change which side is greater, because you're adding the same thing to both sides, whether it's positive, negative, or whatever. So this is always true. And then the last one, you can read this as negative A, but you can also read this as the opposite of A. Just like the opposite of 2 is negative 2, the opposite of 4 is negative 4. You read this as the opposite of A is less than A. Well, let's do a couple scenarios here. So let's say A is 2. Well, the opposite of 2 is less than 2. That's correct. But what if A was negative 2? Then this would be the opposite of negative 2. And we're seeing if that's less than negative 2. Well, the opposite of negative 2 is 2. Is 2 less than negative 2? No, it's not. So sometimes this works, sometimes it doesn't. Just a little brain exercise with inequalities there. The next lesson is going to be using multiplication and division. But for your homework for now, you just got addition and subtraction. Go ahead and work that. You can refer back to your notes if you need to, and then move on to the next lesson whenever you are done.